Hi.
Hi, everybody.
Hi, Professor.
How are you? How is everybody?
Good.
Yeah, very good.
Good, good.
I'm happy. Okay. Did you quiz 4?
Professor, I uploaded the video and it says that it was late.
No?
Huh?
Maybe it was late. It was until today, I think.
Yeah, it was until today at 1:30, but you closed the assignment at 11:59 last night.
Oh, I didn't close the assignment. The system closed the assignment, Raya.
Yeah, I know. So I don't know what's wrong. I mean, you said it was going to be
Let me see. What is this assignment? Can you tell me what's the name of the assignment to remember me? Quiz something, no?
it was under the quiz for the video.
Quiz 4 update video link for the problem of quiz 4, right?
Yeah, it was that one.
Okay, let me put it, let me see. It's going to finish until July the 9th, 1:30. This is what it say here.
For
Professor,
mine,
what happened was that it's the due date. It's saying it was due July 7th at midnight, but it was available until the 9th. So I think that's why it says that it was late.
Okay, so I'm going to change it until 5 p.m. today, can be? 6 p.m.?
yeah, that's fine.
6 p.m. Okay. Done.
I also
Can you change it by tonight? Because I'm not gonna be able to come. I'm gonna be at work until 5. So
9 p.m.
until 5.
until 9 p.m.
Oh, 9 is fine. 9 is fine.
9 p.m. today, okay?
Thank you.
Okay, it's done.
I also have a question about quiz 3 because I received a 0 for it. I was not aware like it was due because I think it was due since like Monday, I think, or Tuesday. And I got a 0 because I didn't know about it until I see.
Just a moment. What you say, Benji?
Quiz 3, I received a 0 for it because I didn't know if it was due on Tuesday.
Quiz 3?
Yes.
Quiz 3 was last week, no? You write me and you let me know what happened, okay?
Okay.
Okay, so let's go to,
Professor, I have a question.
yes.
I sent you an email yesterday. I was taking the quiz on Canvas, and Canvas, like as I clicked to the next question, it said that it was down for maintenance, and it closed the quiz. And I was wondering if you could let me do it again.
Maybe it closed the quiz, was more than 100.
No, I had at least 120 minutes. I sent you a picture of what the screen on my computer said.
Yeah, no, thank you.
Okay, I'll try to.
We're using sex today, so she doesn't want to.
It's later. Please remind me again after class. So I'll try to fix this. And this is for quiz 4, for the quiz.
Yes.
So you said that closed suddenly the quiz and you couldn't finish.
Yeah, it didn't let me log in back on Canvas either.
Okay, you send me an email and tell me open the quiz from this time to this time, and I will do it. Okay.
Okay, thank you.
Okay.
Professor, oh, sorry, I have one more question. There was, you know how you said to do like 2 questions, post them on YouTube, the ones with the police?
Isabella?
Yes.
Hi, how are you, Isabella? Oh, now I can see you. Yes, let me know.
Yeah, so you said to post 2 with the police, but there were several with the police. There was like, I think 4, so I did, it was question 5 and 10, right? just to make sure that I did the right ones for the YouTube video.
It depends. It depends because maybe the system changed the questions, the number of the questions, but it was the only one about the pulley. No to make a mistake.
There was one that was like a 2 kilogram mass, and then there was another one that had like 2 pulleys in the same one.
Right. These
Oh, okay. Just making sure.
only 2 pulley that are on the test. So you solve these 2 pulley. Okay. Okay. Any more question? Can we start? No more questions? No? No? We start. So let me share my screen. Connect. Let me share my screen. So what we talked last day was about work and energy, right? And let's go, if we can end this, let me see. Let me take my pen.
Hello, Professor.
Yes? Hello? Just a moment, sorry that my pen is not being connected to my iPad. Let me see what I can do. Why? Plugging Apple Pencils to use it with this iPad. I plug it. Okay. I do it. So I'm trying to connect my Apple Pencil to the iPad.
Professor, I think what you need to do is that you need to pair the pencil to your iPad.
Yes, so I connect the pencil in my iPad.
Yes, like there's a little top to your Apple Pencil that you need to plug it into where you plug in your charger so that it pairs with your iPad.
Yeah, but they say plugging Apple Pencil to use with this iPad. So how do I plug it? How do I plug it? With other devices, maybe, no?
Like this. You see the top? You take it off.
Yes.
And then this little thing, you're gonna plug it in the charger, like this.
Yes, this is what I did.
Oh, and it's not connecting?
Nope.
You have to click the Apple Pencil thing, like there, you have to click it. Like where it says Apple Pencil in your Bluetooth.
Yes, I do it also. Let me close application. Maybe if I close the application, and let me see now. Okay, let me close the Bluetooth. Let me take the pencil. Let me do it from the beginning. So they say Apple Pencil not connected. I close it, I put it. Plug-in paper to use with this iPad.
Go to the little icon, the blue one, and erase, put like forget, and then like do it all over again.
Forget this.
Forget device.
Yes?
Yeah, and then do it again.
Good idea. Let's go.
And then you see it again in the bottom where it says other devices.
Yes, it's perfect. Thank you. Thank you.
You're welcome.
Yes. Christina?
Yeah.
Thank you, Christina. Okay, so let's go to finish what we were talking about last day. What we were talking is about work. Let me go to another. Okay, we were talking about work. Let's go to review what we have seen. First, what we see first is that in one dimension, the definition of the work was take fx and multiply by delta x, the displacement. What we have seen that in this way we have defined in the x direction the work going from x1 to x2 as the force that is between x1 and x2 divided by delta x. But this definition is in case that fx does not change between x1 and x2. Of course, this definition is if fx is constant, because otherwise, how can we define this work as the force by the displacement if we don't know the force in the middle? If the force is changing, what force we will use here? The force that is here or the force that is at the end? Or the force that is in the middle? If the force is changing, we have a complication here. How we can define the work if the force is changing? 2. In one dimension, we define the work done by the force Fx as small work equal Fx by the small displacement. Can you tell me what I'm doing here? Am I writing down the same thing here than here? Can you tell me if the force is changing what I'm doing? What I'm doing is this calculation. I took a small displacement. This is the displacement from x1 to x2, delta x, the big displacement. If the force change, my definition of work is take the value of the force and multiply by the small displacement. Take the value of the force again and multiply by the small displacement that now is a big displacement. And take the value of the force and multiply by the displacement. So the total work will be the sum of Fx by delta x, a small delta x. Let me write the sum of the force of what is the force in the displacement by the small displacement. Of course, if I put the small displacement, I can change the force in every displacement, and I can consider the force as constant inside each small displacement. You catch the idea? So let's say that the force do like this, Fx and the distance x. So let's say that I stay at the position x1 and x2, and the force is like this, is constant. What is the work? Let's say that the force is Fx, or 10 newtons, if you prefer, or F0. So the distance is this magnitude. The force at the distance is this magnitude. In this case, the force is constant. So my definition of work is that the work is force that exists between x1 and x2, and the force that exists between x1 and x2, F0, 30 newtons, whatever it is, by the displacement. The displacement will be x2 minus x1, and it's from here to here. And the displacement delta x is, if x1 is 3 meters and x2 is 5 meters, the displacement is 2 meters. So by delta x. So F0 to delta x. What I'm saying now is the force is not constant. Let's say that now the force is not constant. What I'm telling you to calculate. So this is the x equal 3. This is the 5. Let's say that the force is not constant. So it stays here at F0. But now the force goes like this. It's going to be higher and higher and higher. So the force increase and increase and increase and increase. How I will define the work? The small work will be Fx by the small delta x. So I will take a small displacement here. This delta x. I will divide the 2 meters that are between 3 and 5 into small pieces of delta x. Maybe I will divide the 2 meters that are between 3 and 5 with x equal 3 and x equal 5. Maybe I will divide the 2 meters into parts. So every part will have 0.2 divided by 10, 0.2. So this will be the 0.3, 0.2, etc. 3.4, you catch it. So I will make this operation. The force here, I will take this force, maybe F0. So the small work will be F0 by the small displacement, 0.2. This is the small displacement. Plus the second one. The second one is F1. The force by the small displacement, 0.2. By the second one, F3. By the small displacement. And like this, I will cover what? The whole work. The work will be the sum. This is the small work done in the first small displacement. This is the work done in the second small displacement. And this is the work done, a small work done on the third displacement. What I will cover if I do this multiplication, I will cover the what? If I do Fx by delta x, and I will sum for all the interval, for all the points, what I will get at the end. If I sum, what I will get? Well, if you see Fx, the value of the force here, by delta x is the small area. If I sum, I will get the area. The sum of all the small areas will be the total area. So the work in this case, in the first case, the work will be 30 by, let's say, x1 equals 3 and x2 30 by 2 will be 60 Newton, 60 joules, the work. And in this case, will be the area that is under the curve. And the area that is under the curve is the sum of two areas. The area of the triangle and the area of the rectangle. So let's go to calculate. So the work in this case, the work will be the area. So the total work will be the sum of all the Fx, all the forces multiplied by the small displacement. And you sum, and you sum, and you sum. So you create the small work. In this case, the work will be the area. What is the area that is here? See a triangle. Let's go to put numbers. Let's go to see that, to imagine that this is 30. Let's go to imagine that this is 60. Okay, so the work will be the area that is under the curve. So the area that is on the curve, this will be 30. 30 by 2 is the area of the triangle. Divide by 2, 1/2 of the height. The height is 60 minus 30, that the height is 30 by 2. Divide by 2, plus the area of the triangle plus the area of the rectangle. The area of the rectangle is 30 by 2. So in this case, the work is 60 plus 30. It's 90. There is more work done because the force has changed. So if the force has changed, it's reasonable that you have made more work than in this case. Catch the idea? Yes or no? Good answer.
I don't know why you, like, I was going to ask you why you divided by 2.
Oh, because the area of a triangle, you have a triangle, the area of the triangle is 1/2 the base by the height, b by h. So the area of this triangle, you see the triangle is 1/2. The base is 2, from 3 to 5, the base is 2. And the height, I said that is 30 because the total height is 60. And until here is 30. Here is 30. So the area of the triangle plus the area of the square, but the area of the square is side by side, 2 by 30. So it's 2 by 30, correct? 2 by 30 is here. Okay, and this is the triangle. So the work done is this. Okay, let's go to see more things of this work. First definition. Definition. We are going to concentrate on the definition of work. First definition. If Fx is constant, the work is Fx by the displacement. Second definition. If Fx is not constant, the small work, I call it like this, will be the force that is on the displacement by a small displacement. And I put it in a small because it's a small displacement. Okay? So maybe delta x1 corresponds to the total displacement divided by 100. Maybe. You can make any as smaller you make the small displacement, as a better result, as more exact result you will do. So the working in this case will be the sum of all the small work from I equal 1 to 100 if you divide it in 100 parts. So you will sum the small work done in the first displacement plus the small work in the second displacement plus the small work in the third displacement, delta x3, etc. And you will cover, but indeed on every displacement, you will imagine that the force is constant and you are using this definition. Third definition of work. Third, if I want to calculate, you see that all the definitions that I'm going to make for work are equivalent. All of them, they are equivalent. All of them, they will say the same thing. If you want to calculate the work done by a force Fs, what does it mean Fs? I know what does it mean Fx. I know what does it mean Fy, but what it means Fs? Let's say that I take the direction S. This is my direction S. And let's say that this is S1. And this is the point S2. And let's say that there is a force Fs. What is the definition of work? Is the force Fs that is on the direction by the change in the displacement on this direction. So this definition is exactly the same definition as taking the x-axis, x1 and x2, and imagine that the x-axis now I will call the s-axis. And I imagine the x1 I will call the point S1. And imagine that the point x2 is the point S2. And I imagine that the force that is here, Fx, is Fs. So this is the definition for the work in the S direction. So the point here is that when you calculate the work, you pay attention to the direction and you use the force that go in this direction. Example, let's say that this is my direction S, and let's say that the force is this one. And you go from the point S1 to the point S2. What is the work? If F is constant, let's say that F is constant, F is here. F is always the same thing. F is constant. It's constant in magnitude, it's constant in direction. But what will be the definition of the work for going from S1 to S2? The definition of the work is take the force on the direction of S and multiply by the displacement. So I will take the force, this force, not this one. I will not take this one. I will take the projection of the force in the direction of S. So I will take Fs, this, and as you know, Fs, if this angle is theta, Fs is the force F multiplied by cosine of theta. So my work now will be my definition, my equivalent definition will be that the work is Fs by the displacement in this direction, and this will be F cosine of theta by the displacement in this direction. So this is another way to see it. Another way to see it. 4. If I take the y direction and I move from y1 to y2, what will be my definition of work if the force is constant? Let's say that the force is constant. The force can go in this direction, maybe. What you say that is my definition of force, of work, will be, if I'm moving from y1 to y2, the displacement will be delta y. I displace from this point to this point. So delta y will be y2 minus y1, final minus initial. So what will be the definition of the work? Take the force that is on the direction S. In this case, S is y, so take Fy. And multiply by the displacement in the direction of y, delta y. So this is another definition of the work when things happen in the y direction. And what is my definition, my general definition? General definition of work. The general definition of work, if the object x, so the x and the y, if the object is moving through a line, he's moving through this point P1 to the point P2. What will be the definition of work going from P1 to P2 when there is a force here? F. What will be? Will be F. So when you move here, you move in the x direction and you move in the y direction through the curve. So the definition of work is take Fx by delta x and take Fy and multiply by y. And this is the general definition in 2 dimensions for the work, okay? So there is another equivalent definition, force, 6. Equivalent. Equivalent, everything is equivalent. The work is the force in the direction of the S by delta S. Is the force parallel to the movement by the displacement in the movement. So if you see it, you see this picture, you take this displacement, the delta S, and you see what is the force. That the force can be like this, but you don't take care of the force where it goes. You take the quantity of force that go in the direction of delta S. So it's F parallel by delta S. If you apply here and the force going like this, you will take note of the force that is going in this direction parallel to the delta S. So you will calculate F parallel and you multiply by delta S. And you will sum. You will sum from point P1 to point P2, and you will be able to calculate the work. So the work in going from P1 to P2 will be the sum of all the parallel force by delta S. But all the displacement, and you sum, and you sum, and you sum, but always taking in consideration the parallel force parallel to the displacement, okay? And to finish, this is the work. Another equivalent the work is F scalar S of delta S. The work is the product, the scalar product, the dot product, the dot product of S, of the force, and the displacement. So if you move in this direction, S, and you have this displacement, delta S, and you have this force, F, what is the work? You project the force onto the direction, and this is my F parallel, this is F parallel, and will be magnitude of F by the cosine of the angle between delta S and F by delta S. This is the definition of the dot product. But magnitude of F by cosine of alpha, this angle alpha, is F parallel by delta S. And again, we have the same definition. So we can see these things in many, many different ways. And the way that you have to take care is this way. The work is Fx delta x plus Fy delta y. Okay, did you catch what I said?
Yes.
Okay, answer me this question. I have the weight, mg, and I move in this direction, delta s, horizontal direction, always, or delta x, because it's horizontal direction. What is the work done by the weight in going to x1 to x2? What is the work done by the weight in going to x1 to x2? Well, it will be the force. If I'm taking the work by the weight, I have to find this displacement. Well, easy to find. It's x2 minus x1. This displacement, this is x2, this is x1, this is x2, and this is the displacement, x2 minus x1, or what we call delta x. We have to multiply delta x by the force. It will be correct to say mg by delta x, and this is the work. In going from the point x1 to the point x2, it will be correct. After all I said, answer this question. It will be correct or will not be correct. The force by the displacement. It will be correct, yes or no? There is here something, votation.
Yeah.
Votation, let me see. Oh, okay. Okay, let me try this, this thing. Let me see. Okay. So how do I do it? Oh. So go to votation and say yes or no.
It's not showing up, Professor.
No? Let me see. It will be correct. I will only write this. Yes, it will. I don't want to write too much, okay? Okay, let me see. I don't know how this works. How it this work? Keep it. Maybe, I don't know how. It say there is a button here in Zoom that say votation. What is that for, votation? I suppose that is making you allowed to say yes, no, whatever, no? Oh, Yes, someone wrote yes. But it's no. The answer is no. Why the answer is no? Because I have said like 7 times that the force that going from x1 to x2 is the force that is in the direction of x. This is the force that has to be taken. And on the direction of x, mg have no projection. So the work is not this one. The work is 0 because there is no force on this direction for going to x1 to x2. Okay? You catch it? I said 8 times that to calculate the work, you must, from going to x1 to x2, you have to pay attention to the force that is on the direction of the displacement. So,
I have a question.
yes?
So would you include the force of the weight if you were looking for the work in general, not just from x1 to x2?
I did not understand your question. You said, I have a force, the weight, mg, and I want to find the work done from going to one point to another point. So I will find the work, this is the force. The force is minus mgj. This is the force. So
if you are writing, we cannot see your screen for some reason.
Oh, sorry. Thank you for telling me. Thank you. Now? No? Not yet, no?
Can you try writing?
Let me try again. No? Sorry. Sorry, just a moment. Nothing. No sharing, right?
We don't see your screen moving.
No, just a moment. Let me try again. Just a moment. Sorry. How made the screen to share? By Bluetooth? I suppose. Let me think. Apple Pencil disconnect? I don't know why. Connected now. Now. I'm sorry, I'm sorry that this happened. Now? Yes, you can see now, right?
Yes.
Yes.
Let's go to what we were. So second question. If you have, so in this case, In the case of the weight, if you move, if this is the X and Y, and you move horizontally from one point X1 to another point X2, you don't make it. The displacement is indeed, this is the vector that is the displacement, delta X. But the force is going perpendicular to the displacement. So as you can see, F scalar delta S will be zero. Is the, this is the word, F scalar delta S. So if F is perpendicular to the displacement, work will be zero. No work is done from X and 2. You can do by this force mg if from G1 to G2. If you move from G1 to G2, the force is constant. It's not moving. So what will be the work? The work will be delta y will go in this direction, delta y. So the force is the force that is projected in this direction, in the direction that I displace, is the force Fy by delta y. So what is the force? The force is minus mg. What is the displacement? Is y2 minus y1. In this case, when you move from here, from y2 to y2, from y1 to y2, you make work. And the quantity of work that you make is this quantity, okay? Is the work done positive or negative? Well, this work is negative because let's say that y1 is 10 meters and y2 is 30 meters. y2 minus y1 will be 20 meters. With minus mg, m is positive, g is positive. Minus mg will be a negative work. And indeed, you see that the force is going in this direction and the displacement is going in this direction, delta y. So if the two vector F S go in opposite direction, the work is negative. If I go from here, from the point 1, this one is my new point, to the point 2, the displacement will be in this direction. This is delta y, and the force mg will go in this direction. So in going to point 1 to point 2, now the work will be positive or negative.
Professor, I have a question.
Yes, good question.
How do you know that the displacement is going up if the object itself is going down?
Well, it's a good question. It's a good question. I did it. I tried to make you to solve many examples in problems. So this is the point P1, and this is the point P2. You go from P1 to P2. Obviously, you displace, and this is the displacement, delta S. How you know that delta S is going up and not going down? Well, this is R1. This is R2. In this equation, you see final position equal initial position plus the change. So the chain have to go up, cannot go down, because if it go down, the picture will say like this. R1, R2. Let's say that you say that delta S is like this. The equation will be R2 plus delta S equal R1. This is the equation that you can write in vector form. So, but we are going from P1 to P2. So this must be the equation. So delta S is going up and the force is going down all the way. So the work is negative. Catch it? Catch it?
Yes, thank you, thank you.
Okay. It's subtle things. There is something that is subtle. You have to be careful with the detail because the detail is important here. So now let's say that you have an object in a circular moment. The object is subject to a force. If he's moving with constant velocity, the acceleration will be v squared over r, and the force, the centripetal force will be the mass by the acceleration, and it's a force that goes to the center always, as I have proved you in many of the videos. So what is the work done by the force F? Fc by delta S. So he's moving from here to here, delta S. He's moving from here to here, delta S. If you want, I can put it delta S1, delta S2, delta S3. And the force is going like this, the force is going like this, delta S4. And the force is going like this. Can you tell me what will be the work done by the centripetal force, Fc by the displacement, the displacement? This is the most general definition of work, of if you want, the force parallel to the displacement by the displacement. How much it will be the work when I go around one turn? The force is doing work. This force, the centripetal force, is when I move in a circle, yes or no?
Could you repeat the question?
Yes. If I have a movement that it consists of a circular movement with constant velocity, so the object is moving like this. The object is moving with constant velocity v in a circle. V in a circle. So he's changing his velocity all the time. I have proved you that the acceleration is v squared over r. So the force, the centripetal force, is the mass by the acceleration. Mass by central acceleration or centripetal acceleration. So the work will be the force by the displacement. And I want, in this case, to calculate the work done by this force. Which force? The centripetal. How I will do? I will use my definition of work. I can use this definition. The force is the dot product of the displacement with the force, the dot product, or I can use this F parallel to the displacement, parallel to displacement by multiplied by displacement. How much will be the sum of all this? Please tell me how much it will be the work. The force, so the object is moving in this direction in this moment. The object is moving, when he's here, he's moving in this direction. When he's here, he's moving in this direction. He's moving in this direction, but the force is always like this. The force here is always like this. When he's moving in this direction, the force is always like this. How much quantity of this force is on the direction of S?
The entire, the radius, sorry, no, what is it called?
What is the component of the force in the direction of the displacement? Let me make the question like this. You have this force, F. What quantity of this force is on the direction of X? Well, this quantity, Fx, this quantity, or this quantity. What quantity of the force is on the direction of Y? Well, this quantity, Fy.
Oh, is it F sine the angle?
Force, just a moment. Now I put the force X like this. And this is the direction of movement, X. What quantity of this force is on the direction of X? Don't you see that if I make this, the projection will be lower? Don't you see that if I make this, the projection will be lower? And when it's perpendicular, there is no Fx. So there is no Fx if the force is perpendicular. So Fx by delta x will be 0 if the force is perpendicular to the displacement. Wow, I have said 10 times, 10 different times in 10 different ways, and you still didn't catch it? Cannot be possible. You are more than that, so please pay attention, because I know that you can catch it. So in other words, what is the work done by the force F? Equal to what? What we proved yesterday, that the work done by the force F is correct?
Yes.
Okay. If this is 0, what is this?
Also 0?
Of course, if this is 0, it's because omega is 0. So let's do our problem. What is V? Constants. What is 1/2 mb final squared minus 1/2 mb initial squared? How much it will be this quantity if V is constant? Well, if this is constant, let's say 3 meters per second, well, will be 1/2 of the mass by 3 squared minus 1/2 of the mass by 3 squared will be 0. So if this is constant, the work done by the force is 0. This is what I have proved, that the change, the kinetic energy is 0 for this force. This force cannot change the kinetic energy. This means that have no projection in the tangential direction of the movement. The force has no projection in the direction of the movement, of the displacement. So if it has no projection, cannot accelerate the object, cannot make change in the value of the vector velocity. This force, like this one, can only change the direction of the velocity. The direction of the velocity is what is changing this force, but not the value, not the magnitude of the velocity. So you have to review again unit what? Unit 3, unit 4, I don't remember. Okay, let's go ahead. So let's go ahead. So I hope you could catch it, this idea. So to resume, the idea is like this, that the work is the force, scalar, the displacement. Let's go to make examples. One, if F is equal minus 10J and delta S equal the displacement is 10I. calculate, find the work. The work is a number, it's not a vector, a number. You have to calculate a number. Second case, if f equal minus 10j and delta s equal 10j, find work. Third thing, if f equal minus 10j and delta s, the vector delta s, the displacement, is 5i plus 5j. Find the work. So I'll give you, it's very important that you see these three calculations, because these three calculations are the basic calculation to find the work. It's all the time the same calculation. So I will give you 5 minutes to do it. If you want, I will make some groups so you can discuss this in groups.
No, Professor, can I ask you a question?
Yes.
You were saying that it's the force dot product with the change in S, right?
With the displacement, with the vector displacement. Or I also said that is F parallel to the value of the displacement, okay? I always say it like this, that this is the say that F parallel by the displacement. Okay? But you know how to do the dot product of two vectors because you did it on unit 2. So make the dot product of these two vectors. That's like this. F is this one and delta S is this one. Make the dot product. And find omega. Find the work. Find the work. Make the dot product in these two vectors and find the work. Make it in this way and find the work. Make the dot product between these two vectors and find the work. The dot product, I already teach you how to make the dot product. And if you don't remember how to make the dot product, make this F parallel to the displacement. The force that is parallel to the displacement multiplied by the displacement. So I'll give you 5 minutes to do it, okay? Yes?
Sure.
Any question? Okay, go ahead.
I don't, are you gonna put us in groups, Professor? Because I don't think we need groups for this.
Yes, you need groups. Go ahead.
Professor, the issue is that when we get put in groups, we don't see this screen. So a lot of us like lose the question.
Make a screenshot of this screen, okay? Okay, please make the screenshot and you will have it, okay? I'm going to make the groups, okay? 1, 2, 3, go. Okay. Okay, Idelma. Hi. Idelma, are you doing the problem?
I'm actually working on it.
Okay. Okay, go ahead. Go ahead.
Thank you.